and welcome back. Let's continue learning. Today we are going to look at redox reactions. Remember, in our previous lesson we said that oxidation and reduction are taking place when the ions are attracted to either the cathode or the anode. So redox reactions, what are redox reactions? Redox reactions are reactions whereby oxidation and reduction are taking place simultaneously. Oxidation and reduction are taking place simultaneously. In Form 1, we define oxidation in terms of oxygen. So we can define reduction and oxidation in terms of oxygen. We can also define it in terms of electrons. So just to remind ourselves, what is oxidation in terms of oxygen? Oxidation in terms of oxygen. So oxidation in terms of oxygen, we say that it is the gain of oxygen. It is the gain of oxygen. What about reduction? Reduction is the loss or removal of oxygen. So let us write a simple equation here for us to see how oxidation is taking place and how reduction is taking place in terms of oxygen. So we can have a reaction where copper oxide, which is a black substance, it is a black substance in color, being reacted with an element like magnesium. At the end of the reaction, you'll have copper and magnesium oxide. So in this case, copper will have undergone reduction, whereas magnesium will have undergone oxidation. Why? Because initially copper had oxygen, it had an oxygen, and it has lost that oxygen to magnesium. So that one we call reduction. Then magnesium didn't have an oxygen, and it now has an oxygen. So it has an oxygen has been gained, or an oxygen has been added to magnesium, and that process we call it oxidation. So this is an example of a redox reaction. So what is oxidation and reduction in terms of electrons? Oxidation and reduction in terms of oxygen, in terms of electrons, sorry. So oxidation in terms of electrons, oxidation in terms of electrons is loss of electrons. Loss of electrons. Whereas reduction is gain of electrons. Let us use an example here also. Let us use an example here of sodium and chlorine. I've not written a chlorine molecule, but I've written a chlorine atom for explanation purposes. When these two react, we shall have sodium chloride compound. The electronic configuration of sodium is 281, but that of chlorine is 287. So in this reaction, we can see that for sodium to be stable, it requires to lose that one electron, and for chlorine to be stable, to have a stable configuration. Remember, a stable configuration means it has the maximum number of electrons in its outermost energy level. So this one requires to lose one, and this one requires to gain one. So when that happens, sodium becomes a sodium ion with a configuration of 2,8, and chlorine becomes a chloride ion with a configuration of 2,8,8. Becomes a chloride ion with a configuration of 2,8,8. So in this case, when sodium loses this one electron, we say that it has been oxidized, or it has undergone oxidation. Whereas, when chlorine accepts that one electron, we say that it has been reduced, or it has undergone reduction. So that is how we define, and that is how we define oxidation and reduction in terms of electrons. Oxidation is loss of electrons, whereas reduction is the gain of electrons. Now, just a quick one, a simple way to remember oxidation and reduction. When you look at these two atoms here, they have an oxidation state of 0. Both of them have an oxidation state of 0 before the reaction took place. But after the reaction has happened, or after the reaction has taken place, sodium has a positive charge. It has a positive charge, or we can say a positive 1. Whereas chlorine, or the chloride ion, has a negative 1. From our mathematics, you can draw a simple number line here. Just a simple one like that. Remember, anything on the right of this 0 is positive. You can write the positive for the purposes of this, though we know you don't have to. We already know that if it doesn't have a sign in front of it, then it is automatically a positive. So we were at 0 when we were starting with sodium. We were at 0. And then we have moved from 0 to positive 1. That is an increase. So that one automatically becomes an oxidation. That one automatically becomes an oxidation. Then we had 0 for chlorine. And we have moved on the negative side to negative 1. So we have reduced. So that one automatically becomes reduction. So that is a simple way of remembering. Where oxidation has taken place and where reduction has taken place. Once you know the oxidation state of the atoms, and you know the oxidation state after the reaction has taken place, that one will guide you to identify where reduction has taken place and where oxidation has also taken place. So in the electrolysis of molten sodium chloride, we realize that we can write equations, ionic half equations at the cathode and the ionic half equations at the anode. So that one also we can refer to, identify where oxidation is taking place and where reduction is taking place based on those reactions. So let us write the equation at the cathode and identify where oxidation has taken place and where reduction has also taken place. So at the cathode, sodium ions migrate to the cathode. So we say that sodium will accept an electron and become sodium metal, this sodium liquid, which accepts an electron to become sodium metal, which is in solid state. Then we go to the anode, where we have a chloride ion giving us a chlorine atom. And remember, we said we need 2 for us to have a molecule. We need 2 for us to have a molecule. And that one now again brings us back here, where we require to balance our equation. Remember, every time you write an equation, You must ensure that your equation is balanced. You must ensure that your equation is balanced. Now, in this case, let us identify where oxidation took place and where oxidation took place and where reduction took place. So here, we were at the positive. We were at the positive. Remember, this is positive 1, and we have gone back to 0. The oxidation state of sodium here is 0. We were at positive 1, we have gone back to 0. So this one will be oxidation, this one will be reduction, because if you draw again that number line, positive 1 here and negative 1 here. So we were at positive 1, we have gone back to 0, so that is reduction. So at the cathode we shall have reduction. And then at the anode, we were at negative 1 and we went to 0. We were at negative 1 and we went to 0. So this one becomes the oxidation. That one will be oxidation. So chlorine will be oxidized, whereas sodium will be reduced. Sodium will be reduced. We can go ahead and also do the identify where oxidation is taking place and where reduction is taking place in aqueous sodium chloride. Aqueous sodium chloride. So in aqueous sodium chloride, we have sodium ions, we have hydrogen ions, which are positively charged. Both of them are positively charged. We have OH ions from water and the chloride ions from sodium chloride. So these are the 4 ions that are going to be present there. We said that these 2 will migrate to the cathode. It will migrate to the cathode. And these 2 will migrate to the anode. Based on our series, the electropotential series that we looked at in our previous lesson, we realized that in dilute sodium chloride, hydrogen ions are going to be discharged. They are going to be discharged at the cathode. Whereas the OH ions are going to be discharged at the anode. They will be discharged at the anode. So let us write these 2 equations. Let us write these 2 equations, the equation at the cathode and also the equation at the anode, and see what happens. At the cathode, we will have hydrogen accepting 2 electrons, so we must have 2 for us to have a molecule of hydrogen gas. So that is the equation at the cathode. Then at the anode we said that the OH ions are going to be discharged. And when the OH ions get discharged at the anode, we have got 2 products. 2 products are going to form here. We shall have water and we shall also have oxygen gas. We shall have water and shall also have oxygen gas. Now, and 4 electrons are going to be discharged because we require 4 of these. We require 4 of OH ions to give us 2 moles of water and oxygen plus 4 electrons. Why 4 electrons? Because every other OH ions getting discharged is giving out 1 electron. Every other OH giving us an electron, being discharged is giving a single electron. So for them for us to have 4, that means you'll have 4 electrons being discharged. Now, remember we said that all our equations must be balanced. They must be balanced even in terms of electrons. Here we have got 4 electrons that are being given out, but here we only accepted 2 electrons. So we need to also balance the equation at the cathode. We need to balance that equation at the cathode, and that means that we will require 4 hydrogen ions to accept the 4 electrons that are being given out here at the anode, for us to have 2 moles of hydrogen molecules, So that is how the equations will be at the cathode and also at the anode. So the other thing we need to do is to identify where reduction has taken place and where oxidation has taken place. Now, we go back to our simple number line. Then we have -1, and here we have -2. Because we are just dealing with small numbers, we will not go to big numbers. We will not go to the other big numbers. Now here, we had hydrogen with a +1. It was charged. It was a +1 charge. Then it has moved down. To 0, because the oxidation state of hydrogen, it is 0. The oxidation state of hydrogen there is 0. So from +1 to 0, that is reduction. From +1 to 0, that is reduction. Then we had -1. The OH. The OH had a charge of -1, and it has moved to 0. The oxidation state of water here is 0. The oxidation state of oxygen here is 0. Specifically, oxygen here is 0. So that one makes it to be oxidation. So at the anode, we are having oxidation taking place, and at the cathode, we are having reduction taking place. So that is how you identify where oxidation is taking place and where reduction is taking place. And since these are happening simultaneously, we say that these are redox reactions. Redox reactions because reduction and oxidation is taking place simultaneously. That one brings us to the end of this lesson today. We shall look at more reactions in our next lesson.